Okay, the first identity is in inverse trigonometry. Identity in inverse trigonometry. Sine inverse of x plus cos inverse of x is equal to pi by 2. Next is secant inverse of x plus cosecant inverse of x is equal to pi by 2. A tan inverse of x plus cot inverse of x is equal to pi by 2. These are called the identities. You can write sine inverse of x as pi by 2 minus cos inverse. A secant inverse is pi by 2 minus secant inverse, and so on. Okay, so then that's the thing. Next is identities is over. Next is reciprocal function. Reciprocal function is like sine inverse of x is cosecant inverse of 1 by x. A cos inverse of x is secant inverse of 1 by x. You have to, cos or reciprocal is secant, x or reciprocal 1 by x. You have to do both, and so on. Tan inverse of x is cot inverse of 1 by x, and so on. Next is negative argument. Negative argument, remember this music, cos, secant and cot. Only in all the three, if you have a minus sign such as cos inverse of minus x, you should write as pi minus cos inverse of x. A secant inverse of minus x is pi minus secant inverse of x. A cot inverse of minus x is pi minus cot inverse of x. Only for these, cos, secant and cot. Any other trigonometric function, inverse trigonometric function such as sine inverse of minus x is minus sine inverse of x. A tan inverse of minus x is minus tan inverse of x. And a cosecant inverse of minus x is minus cosecant inverse of x. This is how you treat a negative argument. You must remember cos, secant and cot, where we write pi minus. Next is general formulas such as tan inverse of x plus tan inverse of y is tan inverse of x plus y by 1 minus xy. A tan inverse of x minus tan inverse of y is tan inverse of x minus y by 1 plus xy. Supposing you want to write as 2, the entire crux of inverse trigonometry is to convert a 2 tan inverse as 1 tan inverse. So imagine this y is also x, then it will become tan inverse of x plus tan inverse of x, which is 2 tan inverse of x, and the right side will become x plus x, which is tan inverse of 2x by 1 minus x square. The same 2 tan inverse of x can be written as sine inverse of 2x by 1 plus x square, and a 2 tan inverse of x can be written as cos inverse of 1 minus x square by 1 plus x square. This will resemble 2 tan theta by 1 minus tan square theta, 2 tan theta by 1 plus tan square theta, and 1 minus tan square theta by 1 plus tan square theta. It will resemble that. So these formulas is also important. Okay, so you must learn all this. And then I went back to doing the sums. Okay, then is the very important thing, which is the graph. You know, you have, if you're plotting a graph, this is x-axis. In trigonometry, you have 0, this is pi by 2, this is 3 pi by 2, this is 2 pi, and this is minus pi by 2, sorry, this is pi by 2, pi, 3 pi by 2 and a 2 pi. This will be minus pi by 2, a minus pi, a minus 3 pi by 2 and a minus 2 pi, and this is plus 1, this will be minus 1, because 0 is 0. So if you're doing a sine graph, sine 0 is 0, sine 0 is 0, sine 90 is 1, sine 180 is 0, sine 270 is minus 1. The values of sine always ranges between plus 1 and minus 1. Sine 2 pi is again 0. So let's plot a graph. Sine 0 is 0, sine 90 is 1, sine 180 is 0, sine 270 is minus 1. And here sine of minus pi by 2 is minus 1. Goes like this. Can you see? And we have to take the symmetrical part where you get plus 1 and minus 1. Sine of minus pi by 2 is minus 1, sine pi by 2 is 1. Take the symmetrical part. And in trigonometry, this is x-axis, this is y-axis. In inverse trigonometry, this becomes your y-axis. This becomes your x-axis. And basically your domain and the range has got interchanged. So the y value ranges between minus pi by 2 to pi by 2 equal to. That's what is your ranges, and your domain x will lie between minus 1 and plus 1. This is about a sine graph. Let's do a cos graph. I'll do a trigonometric graph, 0, pi by 2, a pi, 3 pi by 2 and a 2 pi and a minus pi by 2 and so on. You know cos 0 is 1, cos 90 is 0, cos pi, which is minus 1, cos 3 pi by 2 is 0. So cos 0 itself is 1. and this is minus 1. Cos 90 is 0. One second, hold on. Cos 90 itself is 0. One second. Let me charge my... So cos 90 is 0. Cos 180 is minus 1. Cos 3 pi by 2. So your cos graph is like this. So if you're going to mark the part which is symmetrical, which is from minus 1 to plus 1, can you see this is the region 0 to pi. So this becomes your y-axis and this becomes your x-axis. As I said, it's going to be interchanged because inverse trigonometry. So your y will range between 0 and pi. That's the range. And your domain x will range between minus 1 and plus 1 as usual. So this is about the cos graph. I'll teach you the other graphs later, but let's be familiar with the sine graph and cos graph to start with, okay? So next is, I think we went on to do textbook sums. That's what we did next. So I'll just quickly recap the textbook sums that we did. And exercise 2.1. Exercise 2.1 had sine inverse of minus 1 by 2. Which is negative argument. So minus sine inverse of 1 by 2. Where will 1 by 2 come in the 1 and 2? Sine 30 will be sine 1 by 2, which is pi by 6. So minus pi by 6. Second question is cos inverse of minus root 3 by 2. Cos, secant and cot has got negative argument. So pi minus cos inverse of root 3 by 2, which is pi minus root 3 by 2 in a cos will come in 30 degree, which is pi by 6. So answer is 5 pi by 6. Third one, cosecant inverse of 2. It's sine inverse of 1 by 2. When will sine be 1 by 2? Again 30 degree, which itself is pi by 6. Next is fourth one, tan inverse of minus root 3, which is minus tan inverse of root 3. Where will tan be root 3? At 60 degree. So then therefore it's minus pi by 3. So fifth one is cos inverse of minus 1 by 2. Negative argument, it's pi minus cos inverse of 1 by 2. Cos 1 by 2 is in 60 degrees. So pi minus pi by 3 will become 2 pi by 3. So sixth question, tan inverse of minus 1 is minus tan inverse of 1. So it's minus pi by 4 is the answer. So let's go to seventh question. Secant inverse of 2 by root 3 will be cos inverse of root 3 by 2. So cos root 3 by 2 will be in 30 degree, which is pi by 6. So let's go to 8th question. Cot inverse of root 3 will be tan inverse of 1 by root 3. Tan inverse of 1 by root 3 will come in tan 30. So tan 30 itself is pi by 6. So let's go to 9th question. A cos inverse of minus 1 by root 2 is a negative argument, which is pi minus cos inverse of 1 by root 2, which is pi minus pi by 4, which is 3 pi by 4. So let's go to 10th question. A cosecant inverse of minus root 2. So cosecant inverse of minus root 2 is cos, secant and cot. So it doesn't come under that bracket. So minus cosecant inverse of root 2, which will be minus sine inverse of 1 by root 2, which is minus pi by 4. So that's the next question. So then 11th question is tan inverse of 1 plus cos inverse of minus 1 by 2 plus sine inverse of minus 1 by 2. And can you see a negative argument here, which is pi minus cos inverse of 1 by 2 plus this is minus sine inverse of 1 by 2 and a tan inverse of 1 plus. So then tan inverse of 1 is pi by 4 plus pi minus cos inverse of 1 by 2, which cos 60 degree is 1 by 2. So then 60 is pi by 3. Minus sine 1 by 2 will happen at 30 degree. So it's pi by 6. So you can simply solve this and find the answer. It has to match with your book back. Make sure it matches. Then is a cos inverse of 1 by 2. Cos inverse of 1 by 2. Is it minus or plus? Plus 2 sine inverse of 1 by 2. Plus 2 sine inverse of 1 by 2. Sine will be 1 by 2 in 30 degree. 30 degree is pi by 6. So 2 into pi by 6 will be pi by 3. And this is cos inverse, which is pi by 60 degree, which is pi by 3. Pi by 3 plus pi by 3 is 2 pi by 3. The 13th question is the domain and range. They're asking for what will be the y value for a sine graph. I just taught you, you all know it's between, y is going to lie between minus pi by 2 to pi by 2. If it's a cos graph, you obviously know it's from 0 to pi. Okay, so depending on whatever is the answer, your domain x will be lying from minus 1 to plus 1. So 14th question is tan inverse of root 3 minus secant inverse of minus 2. Can you see negative argument cos, secant and cot? So it's pi minus secant inverse of 2. Tan inverse of root 3. Where tan will be root 3 will be tan 60, which is pi by 3 minus pi plus secant inverse of 2, which can be written as cos inverse of 1 by 2. Using reciprocal function, cos 60 is 1 by 2, which is pi by 3 again. So a pi by 3 and a pi by 3 will be 2 pi by 3 minus pi, and whatever this answer is, you have to write it. So this is the exercise, and then the next question, the next exercise, I did teach you some sums starting from, I think I took from the 11th question. The next exercise, the 11th question, was tan inverse of 2 into cos of 2 into sine inverse of 1 by 2. Take from the right side, sine inverse of 1 by 2. Sine 30 is 1 by 2, 30 is pi by 6. And bring the 2 down, 2 into pi by 6 is pi by 3. Bring the cos down, cos pi by 3 is cos 60, which is 1 by 2. Bring the 2 down, the 2 and 2 get cancelled. So tan inverse of 1, which its answer is pi by 4. Next sum is the 12th question, which is cot of tan inverse of A plus cot inverse of A. You all know this itself is pi by 2. It's an identity. Tan inverse of x plus cot inverse of x is pi by 2. Similarly, this is also pi by 2. And a cot 90. Tan 90 is infinity. So cot 90 will merely be 0. So then let's go to 13th question. 13th question. No, 13th is not there. You have 14th question, which is if sine of sine inverse of 1 by 5 plus cos inverse of x is equal to 1, find the value of x. Take the sine to the other side. Sine inverse of 1 by 5 plus cos inverse of x is equal to sine inverse of 1. A sine inverse of 1 itself is pi by 2. A sine inverse of 1 by 5 plus a cos inverse of what will be pi by 2 is identity. So x has to be 1 by 5. It has to be same for it to be pi by 2. So that's about this sum. So next is we did the 16th sum, which is sine inverse of sine 2 pi by 3. Solve the trigonometry part first, which is sine pi minus pi by 3. And you know pi minus falls in the second quadrant where sine is positive and pi is an even integral, 2 into 90. And hence the answer is sine pi by 3 here. And bring the sine inverse down. Sine inverse and sine get cancelled, hence answer is pi by 3. Let's go to 17th question. Tan inverse of tan 3 pi by 4, which is tan inverse of tan pi minus pi by 4. This is an even integral. Which quadrant would this be? Pi minus is again second quadrant where sine only has what to be positive. This is tan. You have to take only the trigonometry part and solve. So it's tan pi by 4 with a negative sign. It's not positive. Unlike previous sum where it was sine, here it's tan. Bring the tan inverse down. Tan inverse of minus x is minus tan inverse of x. So it will be minus tan inverse of tan pi by 4. What is in the place of x is tan pi by 4. So the answer is minus pi by 4. Very, very important sum. 18th sum. 18th sum is omitted. Okay, 19th. Let's go to 19th, which is cos inverse of cos 7 pi by 6, which is cos inverse of cos pi plus pi by 6. The fact that it's pi plus shows that in the third quadrant where tan, all school taught your children, tan only is positive, but the question is about cos. Take only the trigonometry part and solve, okay? So it's even integral, but it's minus cos pi by 6. And a cos inverse can be brought down, which is similar to cos inverse of x. Cos inverse of minus x, negative argument, which is pi minus cos inverse of x. What is place of x is cos pi by 6. So pi minus cos inverse of cos pi by 6 is what is in the place of x. So cos inverse cos get cancelled. So it's 5 pi by 6. So that completes this. The 20th question is sine pi by 3 minus sine inverse of minus 1 by 2. Negative argument, so it will become plus sine inverse of 1 by 2. And a sine 1 by 2 has to come in 30 degree. A 30 degree is like pi by 6. A pi by 3 plus pi by 6 is pi by 2. 90 degree, and the sign can be brought down, and a sine 90 is just 1. So hence the answer is just 1. So let's go to next sum, which is 21st sum. A tan inverse of root 3 minus cot inverse of minus root 3. Negative argument, cos, secant and cot will have a pi minus cot inverse of root 3. And there's a tan inverse of root 3 outside. You have to open a bracket here. So then tan inverse of root 3 minus pi plus cot inverse of root 3. Can you see this itself is pi by 2? Tan inverse of root 3 plus cot inverse of root 3 minus pi. So answer is minus pi by 2. So like that you can practice all these sums. Apart from that, I would like to do certain sums which are like important for your knowledge. They might say it's omitted, I don't know, but I still want to take it, which is the sum number 5. So you take the sum number 5, tan inverse of root of 1 plus x square minus 1 by x. Here I am introducing you to something called substitution method. You know that the three identities are sin square theta plus cos square theta is equal to 1. A secant square theta minus tan square theta is equal to 1. A cosecant square theta minus cot square theta is equal to. These are the three identities. So if you have to write substitute x square, 1 plus tan square will be better. A secant square theta is 1 plus tan square theta. Or even a 1 plus cot square theta is also fine, but I prefer this one. So then therefore x can be substituted as tan theta. Theta is equal to tan inverse of x. Kattam pottu vechiko. Now do the sum. Substitute tan inverse of root of 1 plus tan square theta minus 1 by tan theta. A tan inverse of 1 plus tan square theta from here, secant square theta, which in the root will become secant theta minus 1 by tan theta, which is tan inverse of 1 by cos theta minus 1 by sin theta by cos theta, which is tan inverse of 1 minus cos theta by sin theta, because cos theta will get cancelled. Whenever you see 1 minus cos x is 2 sin square x by 2. And the sin theta can be written as 2 sin theta by 2 cos theta by 2. Where 2 and 2 get cancelled, sin and sin get cancelled, it becomes tan inverse of tan theta by 2. Where the answer is theta by 2, and theta is tan inverse of x. So the answer is tan inverse of x by 2. So that's one sum which is interesting, which is substitution method. The next is the immediate next sum, which is the sixth sum, which is tan inverse of 1 by root of x square minus 1. The 10 standard identities, x square minus 1 can be secant square theta minus 1. You can bring the 1 this side and tan square theta. So you can substitute x as secant theta or even x as cosecant theta. Cosecant square theta minus 1 is cot square theta. So let's substitute x is equal to cosecant theta. Therefore theta is cosecant inverse of x. Kattam pottu vechiko. Tan inverse of 1 by root of cosecant square theta minus 1, which is tan inverse of 1 by root of cosecant square theta minus 1 is cot square theta. Can you see? So it will become cot theta. Cot square theta, which will become tan inverse of 1 by cot theta, which is tan inverse of tan theta, which is just theta, which is nothing but cosecant inverse of x. So that's substitution. There are certain sums which doesn't involve substitution, such as next sum that I'm going to do is the seventh sum, tan inverse of root of 1 minus cos x by 1 plus cos x. You all know 1 minus cos x. This itself is tan square theta by 2. 1 minus cos x is 2 sin square theta by 2. 1 plus cos x is 2 cos square theta by 2. And a root 2 and 2 get cancelled. So this is still tan theta by 2. The answer is just theta by 2. Or in this case, it's not substitution. It's just x by 2. Because the question says it's x. So answer is x by 2. There's no substitution anything. It's just direct. So next sum is tan inverse of cos x minus sin x by cos x plus sin x. Whenever you have such a format, you have to throw out divided by cos x. So 1 minus tan x by 1 plus tan x. And this itself is like tan pi by 4 minus tan x by 1 plus tan pi by 4 tan x. Because tan pi by 4 is simply 1. 1 plus tan pi by 4 tan x will be tan inverse of tan pi by 4 minus x. So tan inverse and tan get cancelled. This is your answer. So like this is not substitution. This involves just simple solving. These two sums are simple solving. We should know how to solve it. So let's go to 9th question. Is tan inverse of x by root of a square minus x square. This involves substitution. Sin square theta plus cos square theta is equal to 1. So you can take it that side. So you get 1 minus sin square theta. So this is like that. You can substitute x as a sin theta. So then x by a is equal to sin theta. Theta therefore sin inverse of x by a. Kattam pottu vachikko. X is nothing but a sin theta by root of a square minus a square sin square theta, which is tan inverse of a sin theta by an a cos theta, because a square can be taken out common. 1 minus sin square theta is cos square theta, which is just cos theta, which is tan inverse of tan theta, which is just theta. And theta here is sin inverse of x by a. Sin inverse of x by a. So that's what it is. A substitution which involves an a, additional a. It's like a square minus x square. So therefore the sin square theta can go that side. So I would think of substitute. Either cos square theta is also fine, but I would prefer this. Okay, so let's go to next. The 10th question is tan inverse of 3a square x minus x cube by a cube minus 3a x square. The moment I see this, I know it's like 3 tan theta minus tan cube theta by 1 minus 3 tan square theta, something like that. The powers. So x is equal to a tan theta. X by a is equal to tan theta. Theta therefore is tan inverse of x by a. So then therefore it's tan inverse of 3 into a square into x. X is a tan theta. So it will become a cube tan theta minus a cube tan cube theta by a cube minus 3 a cube tan square theta. So then a cube throughout will get cancelled and it will become 1. 3 tan theta minus tan cube theta by 1 minus 3 tan square theta is tan 3 theta. So the answer itself is 3 theta, where 3 into theta itself is tan inverse of x by a. So these are called substitution methods. So then I therefore had covered most sums in this. I have left out some sums which is not so important. Okay. So then miscellaneous is something we'll deal with in next class. Okay.